Hey, what's up guys? This is Akshay from AS Learning, and today in this video we'll be seeing how to build a YouTube recommendation kind of a system using Pinecone. Okay, so the way we see that on seeing some YouTube videos we get another videos as recommendation. Okay, so we'll be creating similar kind of a recommendation results with the help of Pinecone. Okay, so let me first do the installation, and here in this cell I have installed pandas, pytube, numpy, pinecone client and whisper. Okay, so I have connected to Tesla T4. Okay, I am connected to Tesla T4. Then all the things are properly installed. We can ignore this error. Okay, there are some other packages which are needed by few libraries, but we don't need them. Okay, so here I'm importing the modules. Okay, here I've imported OS, Torch, Whisper, Pinecone, Numpy, Pandas and PyTube. Now this is a function for extracting the audio from the videos and saving it down. Okay, so what we'll be doing is we will be taking help of the YouTube class of PyTube package. Okay, we'll be sending the YouTube URL here. Okay, we'll be extracting the audio. Okay, we'll be converting that video to audio. Okay, and then we'll be saving that audio, okay, into the audio data part folder, which will be created below. Okay, so here I have defined my function. Here I've created the folder. Okay, and this is my audio data path. These are my list of videos. So here I've kept just 3 videos for simplicity purposes. Okay, and here I've created a data frame with this list of videos, keeping the columns as URLs. If you do a dot head, you will be seeing the data frame with 3 URLs. Let me do a refresh. As you can see that we have our audio data folder which is currently empty. Okay, now what we'll be doing is we will be creating the files here. Okay, so we have our URLs. Okay, and then we will be applying our video to audio function. Okay, and once we do our video to audio function, we will be having our audios saved into this folder. Okay, and into our data frame we will be having the file names. Okay, file names associated with that URLs. Okay, now here we have the file name file, okay, of the audio associated with a typical URL, and in the audio data we have the respective audios. Okay, as you can see we have .mp3 files. Okay, now later what I'm doing is I'm just setting up my device for using the Whisper model. Here I'm using a base model which is just 140 MB, 139 MB. Okay, then here I'm defining a function where I will be transcribing my audio file. Okay, so I will be converting my audio file into text, which I will be adding as a new column here. So we will be having the video URLs, the name file, okay, and we will be having the transcription of it. Okay, so here we will get our YouTube file, their respective URLs, and now we have the transcriptions. Okay, this might take time. Okay, because we here have 3 videos. Okay, it should not take much time. Okay, meanwhile it runs, let's go down below and see the other part of the code. Okay, yes, so now we have our URLs, file name and transcriptions with us. So now the next thing which we need to do is we need to convert our transcriptions into vectors. We will be saving them into Pinecone. Okay, and then we will be querying for the best recommendation for the video from the database. Okay, that is how the flow will be. Okay, what we did was we had a YouTube URL links, we converted them into audio. Okay, then we, with the help of Whisper, we got the transcriptions, we have the file names in place. Okay, this transcription will be vectorizing them. The vectors will go into Pinecone. Okay, and then using cosine similarity, now we will be finding the best recommendation for any X or any test YouTube or maybe any one of the vector into the DB. Okay, so how to convert these transcriptions into vectors? Now that's the question. Okay, so there are a few ways. You can use OpenAI's text embedding ADA, one of the popular way, but you will be needing credits for it. Okay, and another most popular way is you can use the open source all mini LM. Okay, so here we will be using the all mini LM of sentence transformer. Okay, and for using this model you will be needing Hugging Face token. Okay, so if you don't have your Hugging Face token, you can just do a simple Hugging Face token search. Okay, and into the access token you can create your own tokens. Okay, this is how you can get your Hugging Face tokens here. Okay, now I have entered my Hugging Face token here. You are using the get pass. Okay, and I'll be using the request library for hitting the post request. Okay, as you can see that here I'm hitting the post request. Okay, with the appropriate headers and the inputs. Okay, and then I'll be getting my responses. Okay, so in this way we will be using the all mini model of sentence transformers for converting my transcriptions into vectors. Okay, so here I am applying my query, that means this function. Okay, here I am doing a post request at API URL where model ID is being passed as a parameter. So this model ID is nothing but my all mini. Okay, and I have in headers I have the HF token. Okay, which will go as a bearer token. Then in JSONs we have the texts as input. Okay, these texts are nothing but my transcriptions. Okay, and we'll be just waiting for the entire response to generated. I'm applying my lambda. Okay, and not lambda, I'm applying my function, and I'm getting my embeddings here. So in this way I've converted my transcriptions into respective embeddings. Okay, now what I need to do is I need to push these embeddings into Pinecone. So what we'll be doing in Pinecone is we will be creating an index. We will be initializing a connection to the index. Okay, we won't be creating a separate namespace, but we'll be storing some metadata. Okay, because these all are metadatas, URLs, name, files, transcriptions. We won't be storing the transcriptions, but file name, URL we'll be storing. Okay, and then we have the embeddings. Okay, so here what we do is we'll be entering a Pinecone API key and a Pinecone environment. Okay, now how to get this Pinecone API key and Pinecone environment? If you don't know what Pinecone API key is, Pinecone environment is, or you need a brush up on what Pinecone is, I've already made 2 videos. Okay, the first video on Pinecone explains Pinecone basics and creating indexes and how to do basic operations on indexes. That is the first video. The second video is about metadata filtering and namespaces. Okay, so I'll say if you want to learn more about Pinecone in detail, I'll suggest check those videos and then come here. Okay, but even this is very straightforward. Okay, so here I've entered my Pinecone API key and Pinecone environment. Okay, how to get them? You can just do a simple Pinecone Google, go to Pinecone console link. Okay, and for your respective starter or whatever project you create, just go into API keys section and you'll be seeing your keys. Okay, so here I'm getting my API key and environment, and here I'm initializing the connection to Pinecone. Okay, here I'm creating my index audio search. Okay, it can be video search, audio search, recommendation. Okay, and then I'm checking whether in that list name if there's already an index name with this name. If not, just create this index. Okay, with this name with the dimension of 384. Okay, which was the dimension of the vector. I've kept the metric as cosine, kept the shards as 1, and kept the pot type as s1.x1. So what is this s1.x1? So s1 generally stands for storage. Okay, right now in Pinecone I have not seen the options of choosing storage type, but few months back in the previous version we used to have an option where you can choose it with the purpose of computation and storage. So S generally stands for storage and P stands for better computation, better performance. Okay, I guess P stands for performance. Okay, but so with this setting we will be creating our index. Okay, and this is how I'm connecting to the Pinecone. My connection has been established here and my index is created. Okay, now let me show you the Pinecone instance which is created. Okay, this is what the instance is created. Okay, not the instance but the index. Okay, the index is created. So this is how my audio search index is. Okay, this is where my vector db is hosted. My pod type is s1.x1. okay, x1 I guess maybe some size type. Okay, x1 x2 can be. Dimension is 384. Total pods is 1. Okay, this is the environment. I have chosen the instance of Singapore. Okay, then we can change the configuration or delete it. Okay, what is collection we'll be seeing on later. Okay, and once I click on it, as you can see, it's a GCP compute system. Currently the pod is almost 0. Okay, now you must be saying, when did the vectors enter the db? It happens in the later part of the code. Okay, so we will first jump to that part and then come back here again. So now the next thing what we'll be doing is, we have our indexes created, so we need to insert the vectors into the indexes. Okay, so here as you can see that we are zipping the audio IDs, audio embeddings and metadata. Audio embeddings are nothing but the data frame embeddings. Okay, which is nothing but this. Okay, then we have the audio IDs. These audio IDs are nothing but the vector IDs, which is nothing but the data frame index. Okay, 0 1 2 3, this thing. Okay, and finally we have the metadata. The metadata contains 3 more fields, that is ID. Okay, same as the previous one. URL, this URL, and the transcription. So my URL, transcription, embedding and its indexes, all this data is being pushed into Pinecone in the form of metadata and vectors. Metadata is nothing but the extra information which is associated with that vector. Okay, in this way my data is upserted into Pinecone. Okay, and now here in this code I'm just querying. I'm just telling it pick up the first embedding and give me the top 2 most similar searches for this embedding. Okay, and the way it will happen, it will be using cosine similarity, because when we created the index we have kept the metric as cosine. Okay, and we have got a result. As you can see that the top 2 matches which were returned to us, this is the first one which contains the metadata also. Okay, they have sending with you the ID and the metadata. It contains ID, transcriptions and the URL. We also have a score. Okay, and similarly the other one also. Okay, and similarly we can see the Pinecone results here also. You can do the similar query by vector here also and you can get the results here. Okay, if you want to learn more about metadata filtering and namespace, I recommend you to check my second video on Pinecone. Okay, so let's take a quick recap about what we saw in this video. So what we did was we took few YouTube links, we extracted audio from them. Then from Whisper we converted that audio into text. Then by using all mini LM we converted that text into vectors. With the help of some metadata like URL, okay, and the transcription, we push them into Pinecone, and then we can do a query on the vectors using cosine similarity. In short, this is what we built. Okay, so if you learned something new, okay, do give it a thumbs up, share it with your friends. Okay, and do check the first 2 videos on Pinecone and stay tuned to AS for more such amazing tech stuff. Take care, peace out.